Let's do a couple more examples. This one says, how many meters is 14.4 feet? So I know one thing here. I got 14.4 feet. So I'm going to put 14.4 ft, and I can put it over 1. Multiplication symbol, fraction bar. Now I have to say, sometimes you'll see dimensional analysis, people do it this way with like a long railroad track way, and they start putting their conversion factors like here and here and here and here and here and here. It's the exact same thing. I just prefer to have the math not hidden, but actually explicit. So we got 14.4 feet over 1. I'm going to put feet in the denominator so that it'll cancel out. And then you ask yourself what makes sense, just based on what we have here, to go to. I'm not going to go straight from feet to meters because I don't know that conversion factor. But I do have a conversion factor for feet to inches available to me. And I will use that. Now, you can stop here and put your numbers in if you want to, because you know you've got this right here. However, I usually try to get all my units down first because that's like the part that kind of is the trickiest. So next, I'm going to get inches out of here. So I'm going to get inches gone. And I'm going to go from inches to centimeters, double checking that I do have a conversion factor that helps me do that. Why am I doing that? Because I don't have the conversion factor from inches directly to meters, but I'm getting there because notice how we are currently in centimeters and we have a conversion factor that'll go right from centimeters to meters. So let's do that. Centimeters is in the numerator. It is the only one that's not dead yet, but let's cancel it out. Top and bottom. Now we can go straight from centimeters to meters because we have that conversion factor. Let's fill in our numbers. So inches to feet. There is a relationship there. We know that there are 12 inches in 1 foot. Now you're looking at centimeters and meters, and you're seeing that this conversion factor says that 1 inch is 2.54 centimeters. And then lastly, you've got the meters to centimeters thing. We know that 1 meter is equal to 100 centimeters, according to our conversion factors available to us. What do I do, and what should you probably do when you are done with this? How do you know that you don't need to go toward kilometers or somewhere else down the line? You can tell yourself, I'm done with that dimension or that unit by circling it. Then you can put your equal sign, do your math here, and you get about 4.4 meters as your answer. So that's how you basically do dimensional analysis. We're going to do a slightly harder one where we have something called a rate. You can actually do 2 different dimensional analyses, so to speak, in one problem. So let's look at how that works. Here's a problem. It says a toy car travels 12 centimeters in 1 second. How many miles per hour is it traveling? So this is a rate conversion. It helps to identify the first rate. So let's look at what that will be. So we have a rate here, and it is, to start, 12 centimeters in 1 second. So that's going to be 12 centimeters per second. I'm going to put down 12 centimeters per 1 second. And somehow, through a series of steps, we've got to go from 12 centimeters per second, so this is a distance over a time, to miles per hour. Take a look at the fact that centimeters are going to need to go into miles, so we need to turn centimeters into miles. At the same time, we need to turn seconds into hours. We are taking one rate and turning it into another rate, centimeters per second into miles per hour. Let's see how that works. When you have your dimensional analysis set up like this, you deal with one of the units at a time. I usually start with the top one, but you could turn seconds into hours if you want to. I'm going to turn centimeters into miles through a series of steps. I did add a dimensional or a conversion factor here. You might not know this one, maybe you do know it, but 1 mile is equal to 5,280 feet. So we're going to turn our centimeters into miles somehow. Can we jump straight from centimeters into miles? Not with what we know here, but we can go from centimeters into inches using our conversion factor here. So centimeters goes there and there. You can do your units first, and then I'm going to go from inches to feet because we do have that available to us. So I'm going to cancel out inches. And let's just pretend like we stopped at the problem here. If we stopped at the problem here, we would have the speed of this little car in feet per second, but we don't want that. So we got to keep going, get rid of those feet, and finally, we'll see that when feet cancels out, we can go from feet to miles using this new conversion factor we have here. Now, we're not done with this. So I'm going to put the multiplication symbol there because we still got to deal with seconds, but let's just fill in the distance stuff. So we got inches and centimeters. That relationship we see from our thing is 1 inch is equal to 2.54 centimeters. And then we of course know the relationship between feet and inches. 1 foot is equal to 12 inches. And then we see our new conversion factor here that we have now available in our knowledge bank is the relationship between miles and feet. 1 mile is 5,280 feet. So if we are done with the distance and we want miles to be in our numerator, we could circle it. That basically tells me, and it would tell you, don't do anything else with distance. We still got to deal with time though, because we don't want seconds, we want hours. Now, Although seconds is way over here on the left, we can still deal with it just like we have been doing. So I'm going to run out of room a little bit, but seconds is way over here on the left, but it's in the denominator. So to get rid of something that's in the denominator, we're going to put it in the numerator so it cancels. Now, seconds is going to cancel at a distance, but still cancel. And I'm going to go from seconds to minutes because I know that one. We know, of course, that there are, and I can just put this right in here, there are 60 seconds in 1 minute. But of course, I'm not quite done yet. If I stopped the problem here, I would have miles per minute, but you can see that we're getting close. So we're going to get rid of minutes. Now, because I ran out of room, it doesn't matter that I'm doing down here. Minutes is in the denominator over here, so we're going to put it in the numerator on the next line. If I had more room, I would just put it right next door to it. From minutes to hours. And again, we do have a conversion factor that'll help us get there. We already know that there are 60 minutes in 1 hour. Don't forget to cancel out your units. It's just a helpful problem-solving strategy. So minutes will cancel. Denominator, numerator, gone. And then I know I'm done with the time now, so I'm going to circle hours. That was a longer one, but that's how it works. Now, when you do all your math here, you're going to get about 0.27 or so miles per hour. Much slower than a regular car, but that is a toy car. 0.27 miles per hour is the speed of this toy car. If we knew one rate, centimeters per second, we use a series of conversion factors to convert that into miles per hour. That's how it works.